The question says, prove that the coefficient of x power n in the expansion of this is twice the coefficient of x power n in the expansion of this. Twice the coefficient of x power n in the expansion of this. How do we do that? Coefficient of x power n in the expansion of this. 1 plus x power 2n. The general term tr plus 1 is 2n cr x power r. 1 power 2n minus 1, simple, right? Okay, so coefficient of x power n is equal to what? For x power n, r will be equal to n, as you can observe over here. X power n will imply that r equals to n, and this coefficient will be 2n cn. Is that simple? Yes. What next? Twice the coefficient of x power n in the expansion of this. Let's try to write the expansion of this as well. For 1 plus x power 2n minus 1, you have tr plus 1 as 2n minus 1 cr times x power r. Once again, you have this. So coefficient of x power n, coefficient of x power n, for x power n you will have r equal to n. This will imply this is 2n minus 1 c n. Is that okay? Yes. And what are we supposed to prove in this one? We are supposed to prove that coefficient of x power n in this is twice the coefficient of it. To prove 2n cn is equal to twice of this value. This value is 2n minus 1 cn over here. Yes. How can you go about proving this one? Let's take a look at this question. So, can we begin with the LHS or should we begin with the RHS? We can begin anywhere. Let's try to, this is a complicated version, right? Let's begin with this one. So, proof. RHS is equal to 2 times 2n minus 1 cn. Can I write it simplified? In terms of factorial form, yes, this is 2n minus 1 factorial upon n factorial times the difference of these two. Difference of these two will be 2n minus 1 minus n, which is n minus 1 factorial. Now, if I want to reach over here, what I'll need is 2n factorial upon n factorial, n factorial. There's already n factorial, there's n minus 1 factorial. Let's multiply with the n in the numerator and n in the denominator. Okay. So what you have is 2n. 2n is one thing. 2n minus 1 factorial is already there. Okay. Then you have n factorial and you have n minus 1 factorial times n, which will be n minus 1. Let's write it combined, and what you have over here is, observe carefully, n minus 1 factorial, basically 3 factorial times 4 will actually be 4 factorial, right? So n minus 1 factorial times n is actually n factorial, not n plus 1 factorial, this is n factorial, right? Keep that in mind. N minus 1 factorial times this. So n minus 1 factorial times n will be n factorial, right? And similarly to n minus 1 factorial times 2n, the next term will actually be 2n factorial. This is n factorial, this is n factorial. And do you observe that this is equal to the LHS? Yes or no? Do you observe that this is equal to the LHS? Yes, this is equal to the LHS. And that's a complete proof for this one. That's a proof of this one. Yes. That's all that you have in this question. Is that all? Yes.